Hi everyone, my name is Joseph Gomez, and I will be doing my interprofessional practice assignment and the informal ULAB recycling. My objectives are to understand what informal ULAB recycling is, what are the health consequences of lead, discover the different approaches to reduce lead poisoning from informal battery recycling activities, and to assess the different approaches. So my table of contents, I will go over the informal ULAB recycling. I'll show one figure. Then I will go into the exposure risk of lead batteries and discuss another figure, and then dive into the interventions from different professions. So what is informal ULAB recycling? Informal ULAB recycling, also known as used lead acid battery recycling, is a common practice used for profit in developing countries. Lead-acid batteries, most often used as car batteries, begin to lose energy as it stores after many uses. Once the battery is not functionable anymore, the, as we call lab, is called a ULAB. It is a hazardous waste, with the majority of the battery being lead. Many people from developing countries find profit in this lead, leading them to destroy the hazardous batteries to extract the lead material. The lead is typically extracted in ways it could pollute the environment and harm the extractors, such as through smelting the batteries. This leads to a large environmental issue for both the environment and the people living here. This flowchart just shows the life cycle of lead-acid batteries. As we know, the first step is the material extraction. Later goes on to be distributed. And once that lead-acid battery is used, it can either be possibly repaired or generated after its end of life, recycled, but it is most commonly just disposed. Some exposure risk of the lead and acid batteries. For exposure routes, lead ash contaminates the ground, water, clothing, inhalation, and could also be ingested. The half-life of lead is around 1 month in human blood. In the environment, it is not highly soluble in water, but it can dissolve in water if it is very polluted, such as in very polluted environments. For health effects, it could cause kidney damage, forgetfulness, sleep disturbance, coma, and or death. For my first professional approach, I interviewed my father, who is a Con Edison manager. So while speaking with him, I did disclose to him and all my other professionals that removing the use lead acid batteries from existence was not a solution in this case because of the way it could profit families in underdeveloped countries that use that for their own profit. So he proposed investing in technology and infrastructure to support safer ULAB recycling practices in developing countries in order to ensure that families that benefit from extracting the lead in batteries are still safe. He also said that we could possibly provide funding for the creation of specific recycling centers equipped with proper ventilation systems and gear for workers to handle and dispose of the ULABs properly. He also said that possible partnering with local governments and organizations to offer safety and training programs on handling safely and disposal of ULABs is essential. For my professional number 2, I spoke to my mother, who is an accountant. She said that we could possibly develop financial models to demonstrate the long-term economic benefits of investing in a safe ULAB recycling practice. She also said quantifying the potential cost savings from reduced healthcare expenses associated with lead exposure and estimating the revenue generated from selling recycled materials could also be possible. And then she also said exploring these opportunities for international grants or subsidies to support these efforts could also be very useful. For my professional number 3, I spoke to my boyfriend, who is a technology product manager. He proposed that we could create technology to improve the efficiency, safety of ULAB recycling processes. He also said that developing innovative recycling technologies that minimize lead exposure and maximize resource recovery, which can in turn benefit these developing countries that utilize the lead for their own profit. Lastly, he said exploring the use of automated sorting systems or chemical processes to extract lead from batteries without exposing workers to harmful fumes could be very useful to ensure the safety. So, as my final assessment of these approaches, here's a possible plan that could be enacted with all these professionals' ideas. So, one, you could conduct a comprehensive assessment of the current ULAB recycling practices in the third world countries to identify areas for improvement. Next, we could develop an implementation plan that prioritizes these interventions, such as establishing recycling centers in communities with the highest lead exposure risk. Third, we can engage with local stakeholders, including government agencies and community leaders, to ensure support for the proposed initiatives. Four, we can monitor and evaluate the effectiveness of the interventions over time and making adjustments as needed based on feedback and lessons learned from these communities. And five, we could provide some type of aid to developing countries so that we can learn how to properly extract lead from ULABs and reduce potential contamination in their own neighborhoods. So some of the main challenges that come up with this, when my father, the Con Edison manager, expressed his ideas, the main challenge would be securing funding and resources for these initiatives, as well as navigating different types of logistical and barriers in these countries where they operate. For the accountant, they may encounter difficulties in accurately predicting the financial impact that these plans and initiatives may have, as well as securing these extra funding sources. And for the product manager, they may face a lot of technical challenges in designing and implementing these technologies, as well as resistance from traditional recycling industries who don't want to adopt these new um, lead methods. So the lesson learned throughout all this is while there seem to be many ways to help reduce lead poisoning from ULABs, the importance of effective communication, collaboration, and flexibility is essential to creating a plan and could be very difficult. They would also need to remain mindful of the different cultures and socioeconomic backgrounds and factors of these different communities that are commonly affected by lead exposure or profit based off these lead batteries. And we need to understand how to work with them a little better and adapt to their approaches accordingly in order to provide the plan that is best for them and their safety. All right, here are my references, and thank you so much for listening.